Hello everyone. Good morning. So today's topic majorly around the gateway. So we know the gateway is very critical piece, your first layer of your application of your product. So your uptime for your gateway is very crucial for any system. So if your gateway is not healthy, your entire business will very disaster for your product, right? So our topic regarding gateway only. Also we'll touch upon the portal journey. So initially what, let's say 1 year ago, what kind of service we were using earlier and how we moved to Kubernetes, what service we're using today, and the business growth we have seen in last 1 year, 3 times business growth we have seen. Recently in Diwali, Dhanteras event, we around process more than 10 million order in a day. So we like to share that journey with you and the problem statement first. Okay, let us introduce ourselves. So myself Bijoy Paul, Principal Engineer at Porter. Also Kubestronaut, just recently I became Kubestronaut also, and also my focus heavily in the security domain.
Pawan. Hello everyone, my name is Pawan and I'm currently working as SD4 at Porter, and my daily responsibilities lies in the SRE role where we maintain the uptime and availability of our systems, observability, and also designing the cost optimal solutions.
Thanks. Okay, let's move ahead. Let's talk about what are the basic things we need before choosing any gateway. So let's example, whenever you're thinking of any gateway, what are the basic things you might require? The basic thing should be the routing part, right? But from any load balancer, we get the routing out of the box, right? You get host-based routing, you get path-based routing. But in certain scenarios, you need more advanced way of routing, right? Maybe custom header or any metadata based on you want to do something, which might not your conventional load balancer can provide. That is the basic thing you need. On top of it, you might want to extend it. Let's say, hey, I need some custom logic I need to have. So if I can code there, if I can add some plugin there, so we like to extend that gateway functionality also, right? Also the rate limiting part is a very crucial feature. Okay, because of any buggy deployment client side or maybe some bad actors, you are getting a large amount of traffic. And you know your quota for each of the business flow, each of the API. So you like to have a rate limiting for that specific flow. So it could be path based, or it could be your IP based or user specific, right? What else you might need? So maybe also, so you also want a security on top of it. Okay, you want to handle all the cost related things at the gateway level, or you want to add some security headers at the gateway level. You want a central governance also. Example, gateway means we are using as a public endpoint. Also you want to control what all APIs, what all endpoints are allowed to go public and what all not, right? We have a specific use case where we are giving a timeline to the user. Okay, in staging you cannot have a private public endpoint. But for some use case, for some webhook, they need for some temporary basis, they need to open that for in staging. So we are giving that option through plugin. So all those functionality you want in your gateway level, and also on top of it, the monitoring part. Because the gateway is your entry point. So from there you want your tracing should start. So at least you have a end-to-end journey, end-to-end span. So all of this you want in your gateway. At the same time, it should be cost efficient, right? So it should be under your infra budget with your order, as per your business requirement. And the most important part, any change should be safe. So there is a way you can safely roll out any change. There could be canary change, weighted routing, all those functionality we need from a gateway. So in Kubernetes, let's see what all options we have. On a high level, we have majorly two, the very popular we know ingress is one option, right? And from last 1 or 2 years, gateway API is emerging now. It's a very popular choice. So I believe everyone knows about plus minus of each of the thing, ingress, benefit, disadvantage, and gateway API. I like to touch upon what are the basic thing why we move to gateway API over ingress in Porter. The major thing you want the platform team, the infra team should not be a bottleneck to maintain your route. So we have multiple team, we have multiple service. So for adding a new route, for adding a new host name, there should not be a dependency or hard dependency on the infra side. So we wanted a clear ownership. Hey, route you can manage. You can tell what all route your service want to serve. But the central thing like certificate, domain, or all the security governance, I want to manage at a separate level, at a common place. So there we found ingress is not meeting our purpose because ingress and service has to be in same namespace. But we want gateway API or gateway can be in my central namespace and I can route my traffic to a different namespace for different team. So that is the main reason we moved to gateway API and that helps us to have a clear ownership boundary. Team can maintain their specific route, but the platform team can maintain all the security governance, certificate and domain. Okay, very on a high level, what are the basic components of a gateway API? Let's see that. Like I mentioned, the central part where we want to govern the certificate, domain and all. So for that we have a gateway, that is the entry point. And where you managing your route or configuration, that is your HTTP route. So the ownership of HTTP route for the individual team or individual namespace, right? And the gateway ownership with the infra or the platform team, right? But these are nothing but a standard, a specification. So, but there should be an implementation, right? So gateway API actually help you to have a standard implementation, right? So there could be multiple implementation of this standard. So we are using Kong. There could be other implementation also. Envoy you can use other also, right? So for that to specify that, okay, which kind of gateway I want to use, that is your gateway class. If you are aware of the concept of object-oriented programming, you have an interface and you have a class, right? So you can think of interface can be your gateway and gateway class is the implementation of that interface, right? So that is the purpose of gateway class. But these are all the configuration. But someone should be there who can orchestrate all this configuration. So these are nothing but CRD, gateway class, gateway, HTTP route. But the controller is there who watches for all this configuration, all for the CRD in the cluster. And anytime any change is there, it read those configuration from the Kubernetes API of the CRD and convert into the implementation specific configuration. So example for Kong, there is a single Kong.yml. What controller does in gateway API, it converts that HTTP route to your Kong.yml. So that's a very specific thing controller does. Okay, so this is the major component of gateway API. Let's move ahead. Like I mentioned, the control plane, nothing but the controller who manages all the configuration, but don't play a role in handling the traffic. Your data plane, nothing but the gateway who actually are responsible managing the traffic. Okay, now let's talk about our case study. So this is all about high level, what is gateway API, why you move to gateway API. Now we'll share the case study we have. So 1 year back we moved to gateway API. Earlier we were using, we were in AWS initially. 1 year back we moved to GCP. That time we decided it should not be a lift and shift for us, it should be a re-architect. So we wanted to solve all our problem we had in AWS. So initially we were deploying gateway, Kong gateway as a ECS deployment only. So for every change we need to restart and deploy something. So we wanted to solve that. And how we solved it, what benefit we are getting, that Pawan can help you to give a walkthrough of that. Pawan, over to you.
Thanks, Bijoy. Okay, so I'll briefly touch upon Porter's logistics ecosystem. So as you know, Porter is one of India's major leading logistics and supply chain companies, right? And from tech point of view, we see Porter as a platform that solves last mile and mid mile connectivity problems by instantly providing access to the commercial vehicles for anything which we want to deliver, let's say from your furniture to the industrial goods. Okay, and since a few years after working dedicatedly in the domestic sectors, we have stepped into the international markets, and now we are expanding there as well. Okay, so let's move on to the Porter implementation of Gateway API. So as Bijoy briefly spoke about the Kongs, Kong is the implementation which we have used at Porter, and this is done via KIC. So I'll briefly explain about the spec of individual components which were highlighted earlier. So first is our gateway class. So gateway class is nothing but your main entry point which tells who is the controller. Okay, so anything so basically anything which gets connected to the gateway class, it tells the Kubernetes that this is my controller name, and you have to handle other stuffs like routing, syncs, validations, or applying the configurations to your gateway. Okay. Now the second part is your gateway. Gateway is basically your entry point of any application. So it exposes, as you can see in the spec, we specify a gateway class name, which is, so that's how your gateway connects to the gateway class. Next point is the listeners, where we specify the protocol which will be supported by our gateway. Majorly we support 80 and 443, which you are all aware, I guess, HTTP and HTTPS. And along with that, we can also specify the TLS related configurations, and obviously if within the Kubernetes environment from where we want to allow the routes to be attached to the gateways. And finally, the HTTP route. HTTP route is nothing but your routing logic. It will tell the developers or tell the request from where to come and where to go. So where to come is your gateway part, and where to go is your backend service part. Okay. Okay, so I'll briefly share a high level overview of how we are handling north-south traffic at Porter. So if you see in the diagram, we have 3 gateways. So one is the public gateway, right? Middle one is the Kong gateway, and the final one, which is the last one we have, is the internal gateway. So all of these are gateway API implementations which is used by different vendors, 2 from Google and 1 from Kong. So first, for the public gateway, we receive the traffic, and that's how, with the help of separate components which was discussed earlier, gateway class, gateway, and your HTTP routes. So that's how the request is moved to your Kong gateway. Now at the Kong layer, we handle some custom logics which is required for your business. So let's say if you want to apply rate limiting per API basis, per path basis, or if you want to send some analytics data to the analytics, analytics scanning or security scanning, in fact, as well. So therein, every possible solution that you can think of, which you see it might fit to your use case, that you can implement at the Kong gateway with the help of plugins, which is natively supported by Kong. Okay. Next, we have the internal gateway, which is again the gateway API implementation by Google. Within this, we are handling our traffic to the backend services. The east-west traffic is also handled with by the internal gateway, and that is how our request is finally served by our backend servers. Okay. Okay. So we'll briefly discuss upon each of the points which we were able to achieve by implementing the gateway API in our ecosystem. Okay. So as I think Bijoy briefly mentioned about a big configuration file. So initially we used to have a very big com.yaml file. So if let's say multiple teams had to define their routes and their services, they had to come together, and then they have to work on that single file, which was a very big file, and it got difficult to debug or troubleshoot or even to check for the syntax. At that time, we had some custom solutions to split that file and to validate whether everything is working fine or not, kind of linter checks that we used to perform. Okay, now with gateway, everything is split across multiple HTTP routes. So that's how our one big fat file got broken into multiple CRDs with the help of your HTTP routes and gateway. So now with these HTTP routes, every team is the owner of the HTTP routes and defining and even controlling the plugins related to those HTTP routes. Another advantage that we gained after this was there were no restarts. So when we talk about kong.yaml defining the routes, we have to do a separate deployment. This used to take around 5 to 6 minutes because we had to perform linters, and it was sharing a common config across all the pods. So it used to take a lot of time. But after this HTTP route change, there were no restarts. So controller is always running behind the scenes, who basically watch for any changes which is happening in the cluster. So let's say if there is any addition of new route or any updates in the route, so that is picked up by the controller and it validates and syncs to your gateway configurations. So this way there were no restarts. Then there is another important thing which is supported by Gateway API is the native canary support. So native canary support, as you might know, we can achieve with the help of weighted routing. So that is natively supported in the HTTP routes, and this also helps in our canary deployments to the different backend services, right? And as I previously said, with the split of HTTP routes, each team are the sole owners of defining their HTTP routes and how they want to route to their backend services. So that's how we were able to achieve a clear ownership. But previously we used to have, if anything breaks, they will reach out to the platform team. So that were becoming a kind of bottleneck on the platform team. So with the help of this, we were able to move away from, the dependency on the platform and eventually cleaning up the, developer velocity times. With this, safer upgrades also became possible, since the controller is always in place and we are also having some linter checks performing in the background. So with the help of this, any, let's say, syntax errors, so anything, things like that is caught pretty earlier, and that's how we are able to achieve a safer upgrades. Okay, moving on to next. We will highlight some of the benchmark stats that we are currently running and serving the scale to, process 1 million orders a day. Currently, you can see there are 95 active pods running for Kong layer, since this is self-managed, and throughput is at the peak is around 16K per second, which you can translate into minutes and hours or day. It will eventually lead to your millions of numbers. CPU usage, we are keeping it around 70%, so that we have 30% enough buffer to handle, sudden spike of the request. And the first thing, I think, one of the most important features which were highlighted in the beginning was the developer velocity. So with this change, and I mentioned HTTP route is nothing but a config. So we were able to achieve the lead time of less than 1 minute. So any change in the route, it gets immediately deployed within a minute. So let's say if there is a production scenario or production issue happening and we want to shut down traffic, or let's say we want to introduce new services, so that only takes 1 minute. Bijoy, would you like to talk about some key decisions?
Thanks, Pawan, for giving walkthrough on the performance stat. I believe you might have some questions in your mind by reading the few design choice we had. So let me tell you something upfront we took as a consideration. So first of all, why Kong? So during migration, we could have chosen any new gateway, or you can simply load balancer only, because for GK load balancer also it supports gateway API. So why we need after load balancer a separate Kong as a separate gateway API layer? Because we already had few custom plugin written there, and which was not supported, is today also not supported out of the box in load balancer. So for that logic, all those business logic, we had to use Kong there. And also the Kong performance before migration also, it was very good. So we wanted to continue with that. That is the first consideration. Second, so the main benefit of Kubernetes, one of the benefit of Kubernetes, like you don't need a separate load balancer to talk to one service to other service, right? You can use cluster IP, or you can use kube proxy through, you can connect to any other service. Then why for even for east to west also, we are using a private load balancer to talk to other service, right? The main reason was the load balancing, because in our service, as the HTTP client, we are using persistent connection. By persistent connection, I mean we are using either HTTP2 connection or gRPC, where it reusing the connection. It's not reopening a connection every time. So in that case, if you use kubeproxy can only help you with the load balancing for new connection, but not for every request. So once it actually worked as a discovery, right? So let's say you are running 10 point. So it will help you to discover one pod IP. But now my client know that IP and it will send all the traffic to the same IP only, right? So that is the problem we had. So for that reason, we use load balancer to terminate that persistent connection there and let load balancer to do the load balancing across the downstream pod. Then there could be the obvious question would be then, okay, there is other chance answer is there is why not service mesh, right? Because if you are going through load balancer, then maybe you are adding a bit more network latency, which was already there in AWS anyway. But so we don't want it to use service mesh only for load balancing, because service mesh purpose is not only for load balancing, right? Circuit breaker and other things also, and which comes with more other things as well. You need more operational effort, you need more learning curve. So that was the main reason, and that point of time we didn't have any use case beyond load balancer for service mesh. That was the reason we wanted to keep it simple, and we went for this architecture. And with this design only, like Pawan mentioned, the throughput we were able to handle today, and also the application we optimized. So that helped us to handle this kind of throughput. Before closing our talk today, a few recommendations we like to share with you. The first thing, for any new solution, for any new implementation, the first approach should be think from a platform perspective. Okay, how it can be reusable for other use case, how it can be self-serve. So example like the use case we are using at Gateway, the gateway and gateway class we are responsible, platform team responsible, the infra team responsible. But HTTP route, what kind of route you want, that is responsibility on the team side. So it should be self-servable, okay? Also, like I mentioned, why we didn't move to service mesh, because we focused on a must-have requirement. So that at that point of time, requirement was to have minimum latency, but with proper load balancing with the persistent connection, not beyond that, because circuit breaking kind of functionality, it was already there in the application level. But as a best practice, we know it should be outside of the application, but that was a must-have requirement. So we should focus on our first must-have requirement first. And also we should check about the ROI. Let's say the present business requirement we had that point of time, the load balancing part, the minimum latency, uptime, HA. And if that point of time, look for the other feature like circuit breaking, MTLS, authentication, other thing. So we need to always think of what is business required now, the ROI part. But at the same point of time, our solution should be in such a way it can support the future use case. Example, today we are using Gateway API, right, which is nothing but a standard and specification. So tomorrow, if I am using the same HTTP route, I can anytime switch to any other gateway, because at the configuration level, nothing gonna change, except some vendor specific thing like plugin. But all other your configuration, your certificate, all these things will be remain same with any other implementation. So this is the principle we feel should be followed before choosing any new solution or principle. Okay, thank you. Any question?